Kitchens, according to the National Electrical Code, require a minimum of two 20-amp small appliance circuits, one 15-amp refrigerator circuit, and one 15-amp dishwasher circuit. Modern appliances often consume more power, so exceeding these minimum requirements is frequently recommended. Refrigerators, dishwashers, garbage disposals, and electric hot water heaters should have dedicated circuits to prevent overloading and ensure reliable operation. All kitchen countertop outlets and outlets within 6 feet of a single water source require ground fault circuit interrupter or GFCI protection. A recommended circuit configuration for a kitchen could include firstly, two 20-amp small appliance circuits for toasters, microwaves, coffee makers, blenders, and similar appliances. Secondly, one 15-amp refrigerator circuit dedicated to the refrigerator and GFCI protected. Thirdly, one 15-amp dishwasher circuit dedicated to the dishwasher and also GFCI protected. And fourthly, one 20-amp circuit for the garbage disposal and electric hot water heater if applicable. Wiring the refrigerator to its own circuit with a home run to the panel is generally preferred. This ensures a dedicated circuit for the refrigerator. Whether this circuit configuration is overkill depends on the specific kitchen and the appliances being used. If a large kitchen with many high-power appliances exists, providing additional circuits to avoid overloading is preferable. If a smaller kitchen with modest appliances exists, the recommended circuit configuration should be sufficient. Consider using arc fault circuit interrupter or GFCI breakers on kitchen circuits for added protection against electrical fires. Label all circuits clearly at the panel for easy identification and troubleshooting. Consult with a licensed electrician for guidance on specific circuit configurations and local code requirements. It is important to note that exceeding the minimum code requirements can provide a greater degree of safety and convenience. Consider the following points for each of the major kitchen appliances. For refrigerators, a dedicated 15-amp circuit is recommended to prevent nuisance tripping. GFCI protection should be provided as required by code, but locating the receptacle and GFCI device strategically can minimize the likelihood of tripping. For dishwashers, the dedicated 15-amp circuit is also recommended. Many dishwashers have built-in heating elements for drying, which can draw a significant amount of current. GFCI protection is typically required for dishwashers. For garbage disposals, a dedicated 15-amp or 20-amp circuit is recommended depending on the size and power of the disposal. Check the appliance's nameplate for the amperage requirements. For electric hot water heaters, a dedicated 20-amp circuit is generally required. Ensure that the circuit breaker and wiring are properly sized for the heater's wattage. For small appliances, the two required 20-amp small appliance branch circuit should be sufficient for most kitchens. However, if multiple high-wattage appliances are frequently used simultaneously, it may be beneficial to add a third small appliance circuit. Ground fault circuit interrupter, or GFCI, protection is crucial in kitchens due to the proximity of water. These devices monitor the current flow in a circuit and quickly shut off the power if a ground fault is detected, which can help prevent electrical shock. Ensure that all countertop receptacles and any receptacles within 6 feet of a sink or water source are GFCI protected. This can be accomplished by using GFCI receptacles or by installing a GFCI circuit breaker. Arc fault circuit interrupter, or GFCI, breakers provide an additional layer of protection against electrical fires. These breakers detect arc faults, which are dangerous electrical discharges that can occur due to damaged or deteriorated wiring. GFCI breakers are now required in many jurisdictions for kitchen circuits. When planning your kitchen electrical circuits, consider the following additional tips. Firstly, create a detailed load calculation to determine the total power demand of all appliances and devices in the kitchen. This will help you ensure that you have enough circuits to handle the load. Secondly, use appropriately sized wiring for each circuit. The wire gauge should be selected based on the circuit amperage and the length of the run. Consult the National Electrical Code, or NEC, Table 310.15 for guidance on wire sizing. Thirdly, use high-quality electrical components such as receptacles, switches, and circuit breakers. This will help ensure the reliability and longevity of your electrical system. Fourthly, label all circuits clearly at the electrical panel. This will make it easier to identify and troubleshoot circuits in the future. Fifthly, consider the future needs of your kitchen. If you plan to add new appliances or devices in the future, it may be wise to install additional circuits now to avoid having to add them later. Sixthly, consult with a licensed electrician for assistance with your kitchen electrical design and installation. An electrician can help you ensure that your electrical system is safe, code compliant, and meets your specific needs. Here's more detail on calculating kitchen circuit loads. The National Electrical Code, or NEC, provides guidelines for calculating the load on kitchen circuits. For small appliance branch circuits, the NEC requires a minimum load of 1500 volt-amps per circuit. This means that each 20-amp small appliance circuit must be capable of supplying at least 1500 volt-amps of power. To calculate the total load on a circuit, add up the volt-amp ratings of all the appliances and devices that will be connected to the circuit. The volt-amp rating of an appliance can typically be found on the appliance's nameplate. If the nameplate only lists the wattage, you can convert watts to volt-amps by dividing the wattage by the voltage. For example, a 120-volt appliance that draws 600 watts would have a volt-amp rating of 5 amps. For dedicated appliance circuits, such as those for refrigerators, dishwashers, and garbage disposals, the NEC requires that the circuit be sized to handle 125% of the appliance's nameplate rating. This is to account for the fact that these appliances may draw more current than their nameplate rating during startup or peak operation. For example, if a refrigerator has a nameplate rating of 5 amps, the dedicated circuit for the refrigerator should be sized to handle at least 6.25 amps. When calculating the total load on a service, it is permissible to apply a demand factor to the small appliance branch circuits. The demand factor recognizes that not all appliances will be used simultaneously. The National Electrical Code, or NEC, allows a demand factor of 75% to be applied to the total load of the small appliance branch circuits. This means that you can reduce the total load of the small appliance branch circuits by 25% when calculating the overall service load. The location of receptacles in a kitchen is also governed by the National Electrical Code, or NEC. The NEC requires that receptacles be installed so that no point along the countertop is more than 24 inches from a receptacle. This ensures that appliances can be easily plugged in without the need for extension cords. Receptacles should also be installed on any island or peninsula countertop that is 12 inches or wider. These receptacles must be GFCI protected. In addition to the general receptacle requirements, the NEC also has specific requirements for receptacle placement near sinks. Receptacles must not be installed within 6 feet of a sink unless they are GFCI protected. This helps to prevent electrical shock in wet areas. When installing receptacles, it is important to use the correct type of receptacle for the application. Standard 15-amp receptacles are suitable for general use, while 20-amp receptacles are required for circuits that supply 20 amps. Tamper-resistant receptacles are also recommended, especially in homes with young children. These receptacles have internal shutters that prevent objects from being inserted into the slots, which can help to prevent electrical shock. The type of wiring used in a kitchen must also comply with the National Electrical Code, or NEC. Non-metallic sheet cable, or NM cable, is commonly used for general wiring in residential buildings. However, in some areas, conduit may be required or preferred. The size of the wiring must be appropriate for the circuit amperage. The NEC Table 310.15 provides guidance on wire sizing based on amperage and temperature rating. When running wiring in a kitchen, it is important to protect the wiring from physical damage. Wiring should be run through walls, ceilings, and floors, and should be secured to framing members. Where wiring is exposed, it should be protected by conduit or other means. The electrical panel is the heart of the electrical system. It is where the circuit breakers are located, which protect the circuits from overloads and short circuits. The electrical panel must be properly sized to handle the total load of the electrical system. The size of the electrical panel is determined by the service entrance rating, which is typically measured in amps. The service entrance rating must be sufficient to handle the total load of all the circuits in the building. When installing an electrical panel, it is important to follow the manufacturer's instructions and all applicable codes. The panel should be mounted securely and should be properly grounded. The circuit should be labeled clearly so that they can be easily identified. Grounding is an essential safety feature of any electrical system. Grounding provides a path for fault current to flow back to the source, which allows the circuit breaker to trip and to energize the circuit. Grounding also helps to prevent voltage from building up on metal surfaces, which can cause electrical shock. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor, which connects the grounding electrode to the electrical panel. All metal enclosures, such as electrical boxes and appliance housings, must be properly grounded. Electrical safety is paramount when working with electricity. Always turn off the power to a circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a licensed electrician. A licensed electrician has the training and experience to safely and properly install and repair electrical systems. When hiring an electrician, be sure to check their credentials and references. Ask for proof of insurance and licensing. Get a written estimate before work begins. By following these guidelines, you can ensure that your kitchen electrical system is safe, reliable, and code compliant. Remember to consult with a licensed electrician for assistance with any electrical work. They can help you ensure that your electrical system meets your specific needs and complies with all applicable codes. Also remember to always disconnect power before performing any electrical work. Test for voltage using a reliable meter before touching any wires. Never overload circuits. Use ground fault circuit interrupter or GFCI protection near water. Use arc fault circuit interrupter or GFCI protection for added safety. Inspect wiring regularly for damage. Replace damaged wiring immediately. Keep electrical panels clear of obstructions. Label all circuits clearly and consult with a licensed electrician for any questions or concerns. These safety measures can help prevent electrical shocks and fires, ensuring a safer home environment. Always prioritize safety when working with electricity. Following these guidelines can help you create a safe and functional kitchen electrical system that meets your needs and complies with all applicable codes. Remember that electricity can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, hire a licensed electrician. Remember, local codes may vary. Always consult with your local building department and a licensed electrician to ensure that your kitchen electrical system complies with all applicable codes and regulations.